Hello, welcome to part 2 of Biology, AQA, Paper 2, 2018 series, higher tier. Okay, so we've got to question 2. Okay, it's about carbon dioxide in the atmosphere. So it says many scientists think that global air temperature is related to the concentration of carbon dioxide in the atmosphere. Figure 3 shows changes in global air temperature and changes in the concentration of carbon dioxide in the atmosphere. So on this axis, change in air temperature since 1955 in degrees Celsius. That's a change, not the actual temperature change. Concentration of carbon dioxide in the atmosphere in parts per mil. So it's parts per 1,000, actually, not per million. So it's gone all the way up here, and the year, so it's the time. So, let's have a look at the question. Complete table 1, this one. Choose answers from the box. You may use each answer once, more than once, or not at all. Okay, so we've been given one. Trend in carbon dioxide concentration 1960 to 1977, increasing. 1977 to 2003, okay, trending carbon dioxide concentration. So that's carbon dioxide, that's squiggly one there, is carbon dioxide, and that's air temperature. Okay, so yeah, in black and white again, it's not that clear sometimes, is it? It's got different colours, it'd be clearer. So carbon dioxide has been increasing the whole time. It goes up and down seasonally, and we'll get to, I think there's a question about that later I looked up. It goes up and down. It's because of summer and winter, okay, because I remember seeing this first of all and wondered why it was going up and down, because the general trend is increasing. It's just the seasons that cause that, and that'd be a question later. Okay, so it's been increasing all the time. So in both these boxes we'd put increasing. Increasing. Okay, so trend in air temperature, maybe it is not exactly the same. We'll have a look. Trend in air 1960 to 1977. 1960 to 1977. Actually, the trend is going down. Okay, it's actually decreasing. So yeah, so this isn't a straightforward thing, is it? We're going to find out. Okay, maybe there's more than just carbon dioxide affecting it. Okay, 1977, 2003. 2003 is a bit over here. That is increasing, and then it sort of flattens out. Okay, so it actually increases. And then constant. It kind of flattens out. That's what I'm saying. I'll draw on it for you to see. Right, so yeah, from here to here, it's going down. Then it goes up to about here, about what's 2003. Then it's pretty much straight. It doesn't. I wouldn't say it's increasing overall. That's pretty. It varies, but I think that's pretty much constant. If you took an average, that would be pretty constant. Oh, Mr. T off there. Constant. Okay, 2 marks. Many scientists think that an increase in carbon dioxide concentration in the atmosphere causes an increase in temperature. How would an increase in concentration of carbon dioxide in the atmosphere cause an increase in air temperature? So we know carbon dioxide is a greenhouse gas. Okay, so what it actually does, so it's only 1 mark, so we don't have to go too much detail because this could be quite a complicated question if you wanted to be. Carbon dioxide, what it does is it actually absorbs infrared radiation. Okay. It has to be infrared. They won't accept light or anything like that because it's not actually like infrared. Evaluate evidence. Yes, this is what I thought they were going to ask about. Okay, evaluate evidence. This is not 6 marks, 4 marks. They're not quite as involved as the neurone question. Evaluate evidence for and against the theory that an increase in the concentration of carbon dioxide in the atmosphere causes an increase in air temperature. Use data from figure 3 and your own knowledge. Right, so, right, let's do a for and against then. I will say, so for the theory that carbon dioxide causes an increase in air temperature. So, I'll do it as a bullet point. See, it's a 4 mark, it's not a 6 mark, so you don't have to do it in continuous prose as much. So, so overall, so in the whole graph, overall, an increase in CO2, the carbon dioxide, has been followed by an increase in air temperature. Oh, okay, in air temperature. So overall, they've both gone up the whole time. Let's get the end's got cut off the computer. Okay, and we know from other questions, CO2, you could say traps IR infrared radiation. We just talked about that. It has to be infrared. So against the theory. So we've got, we need at least for 4 marks, we need 2 for and 2 against at least. Okay. So yeah, as we said, it's not straightforward. Okay, so in some time periods, as we saw, CO2, what I said to you short, CO2 rises, but temperature falls. So example, there's that period, wasn't there, 1960s, 1977, the beginning of the graph, the temperature actually fell, okay? So you could also say other factors may be involved. Like I said, you can see there's probably something else going on, probably as well there. Okay. Aha, this is a question I knew was going to come up. Okay. In each year, the concentration of carbon dioxide in the atmosphere is higher in the winter than the summer. Give one human activity that could cause the higher concentration of carbon dioxide activity in the winter. Okay, so you could say, because obviously it's winter, it's cold, so you could be burning fossil fuels for heat or warmth. Okay, there's only 1 mark. Give one biological process that could cause a lower concentration of carbon dioxide in the summer. So yeah, this is always it falls during the summer because there's more plants and it's photosynthesis. Think about the plants are photosynthesizing more in the summer because they've got more leaves, okay, and they're all more active, and that actually decreases the carbon dioxide. Okay, next thing. Give 2 possible effects of an increase in global temperature on living organisms. Okay, it's interesting. There's lots of different things. You could have, because living organisms, plants or animals, so you could say actually that some plants could grow faster. Okay, you also could have migration of animals. Okay, so it's got to be specific about the temperature, not just about, when we talk about climate change, no talk about different weather, but this is just asking about the temperature. Okay, so other things about weather. Okay, so you could say, or like you could have things like loss of habitat. Okay, because plants die quicker. So anything that's actually could be explained is okay. Okay, but just saying like obviously death, disease, it's not enough for that answer. We've got to say what caused it. Right, okay, so we'll cut this question between 2 pages. Number 3, so something different now. It is important to maintain water balance in the body. Figure 4 shows how much water a person gained and lost by different methods in one day. Let's go down to figure 4. So water gained by the body, volume in centimetres cubed, food, drink, metabolism. Okay, drink you'd expect to be the highest. Water lost from the body, urine, yeah, expect that to be the highest one. Feces is not there, so I'm guessing we're going to put it in. Skin, so that's like sweat. Breathing, here you breathe out, water vapor. Okay, so let's look at the question. When water is balanced, the volume of water taken in by the body is equal to the volume of water lost in the body. So it's balanced, that makes sense. Calculate the volume of water the person lost in one day in feces. Use information from figure 4. Okay, so let's have a look. We need to add it all up, don't we? So 500. I get a calculator because you can always use a calculator. You don't have to do this in your head, and I won't do it in my head either. Get a calculator. Okay, so we've got 500 plus, that's this one, 1,500 plus 400. Okay, so total was 2,400 for this one. So let's write that down before we forget. So water in is 2,400. Water out. Right, so it's got to add up to the same, isn't it? So let's see. Right, 1,500 plus 400 plus, look at the scale on that, 380. 2280. Okay, so obviously we need to work out the difference. 2,400 minus 2280 equals 120. Again, don't doubt yourself doing a calculator, it's fine. That's the only thing I could probably do it on my head, but just in the exam, always check it. Yeah, 120. So that's actually quite easy marks, and it just it could be a maths paper, that couldn't it? Even have to know anything about biology. Okay, just to know that it's adds up to something. Oh, yeah, you don't have to do it in our heads. Right, okay, 3.2. Figure 4 shows that one method of gaining water is by metabolism. What metabolic process produces water? Oh, that's interesting. Okay, breakdown of protein to amino acids, not known to produce water. Changing glycogen into glucose, digestion of fat, or respiration of glucose. Right, okay, respiration is like burning something, basically. Okay, and when you burn something, you always produce water. If you burn fossil fuels, it also produces water, so it's respiration. Okay, only one to tick there. The next day, the person ran a 10-kilometer race. The volume of water lost from the body through the skin and by breathing increased, as you might obviously assume. Explain why more water was lost through the skin during the race. Okay, so obviously more sweating. Okay, we know that. If you run anyway, you can sweat. So more sweating, so that's through the sweating. Okay, and why? Explain. Okay, so because you've got 1 mark for that anyway, that was quite good because the body heats up during exercise and sweating cools the body down. Okay, right, so I'm going to stop the video there, and I'll see you in the next part to go on to the next part of the question. Thank you for listening. Goodbye.